in the equilibrium of force system, we need to apply the equations summation x equal to 0, summation y is equal to 0, and summation moments is equal to 0. So equilibrium means that all forces are balanced for that system. So the technique that we need to apply is the FBD, or the free body diagram. The free body diagram is an isolated view of a body that shows all the forces acting on it. So to have a clear understanding of how to solve for these kinds of problems, let us take this problem. The frame as shown here is supported by pivots at A and B. Neglecting the weights of these members, find the force at points A, B, C, D, and F. Okay? And you observe that there is only one load of 2,000 pounds. So this 2,000 pounds will be supported by the whole frame. So we are going to start at support A. If this support A is removed, it means that this whole frame will topple down to the right because of this load. So in order to prevent that from falling, we need to apply a force AX to hold that in place. Now if we also remove the support at B, the whole frame will collapse downward. So we need to apply the force of By, the vertical support, and this one will also move to the right if it is pivoted at A, so it means that it needs to be supported with B sub x as the force. So if we are going to take summation moments at point B for the whole system, that should be equal to 0 because that is in a state of equilibrium. So to conduct this moment equation from point B, we look at the load of 2,000 pounds, and the distance of 2,000 pounds from point B is 8 plus 4, that is 12 feet. Then we have A sub x as the support, that is negative because it will produce a counterclockwise direction on point B, and the distance is 12. And that is equal to 0. So A sub x can be computed, that will be equal to 2,000 times 12 over 12, and this one will cancel out. So A sub x is equal to 2,000 pounds. So that is one of the answer for point A. To solve for By, we are going to take summation y is equal to 0 for the whole system. So that means it will be By going up minus load, which is 2,000, is equal to 0. So By is equal to 2,000 pounds. So in order to solve for Bx, we also need to take summation moments at B is equal, is equal to 0. So at A, the load is 2,000 pounds times the distance of 12 feet minus Bx times the distance also of 12 feet is equal to 0. So Bx can be computed with a value of 2,000 pounds also. So we already have By, Bx as our answers for A and B. To compute for the load and forces at D and F and at point C, we need to isolate this bar CDE, a horizontal bar here, and apply the loads on this bar. So at point E, we have a load downward of 2,000 pounds. At point D, we have a support there, and it should be supported with an upward force dy, and at C it should be supported going down so that this whole thing will not rotate. And due to the support at FD, at point D, there is a force coming from bar FD going to the right. We call that one dx. And to balance dx at point C, there should be a force going to the left, cx. Okay, we are going to analyze this bar CDE with all the forces already installed. So to compute for dy, we need to have summation moment at C is equal to 0. So the equation would be 2,000 pounds times the distance of 12 feet minus dy, because it is producing counterclockwise direction, times 8 is equal to 0. So dy can be computed with a value of 3,000 pounds. So that is also one of the answers. Then we are going to observe that there are 3 vertical forces. So in order to solve for Cy, we can take summation y is equal to 0. So that will be negative Cy plus dy minus 2,000 is equal to 0. So negative Cy plus dy is 3,000 minus 2,000 is equal to 0. So Cy can be computed as 3,000 minus 2,000, that is 1,000 pounds. So this is one of the answers for pin at C. So in order for us to solve for the point here, F, the loads there, we need to transfer the forces here, dx, to point D here. So dx is going to the right. It should be drawn the opposite direction on point D. And dy is pointing upward, so it should be pointing downward on this bar FD. In order to balance FD, dx, there should be a force going to the right. We call that one Fx. And for dy, which is going down, it should be balanced with an upward force here, Fy. So we are now going to solve for dx, because dy has a value. So to do that, we need to take summation moments at F is equal to 0. So we have dy times this distance, which is 8 feet, minus dx with this distance equal to 6 feet is equal to 0. But dy has an answer already of 3,000 pounds times 8 minus dx times 6 is equal to 0. So dx will have an answer of 4,000 pounds. That is also one answer for D. So going back to solve for Cx, we need to refer back to FBD of bar CDE. So this bar CDE has forces Cx and Dx, which are oppositely directed. So if we have summation x is equal to 0, so we have negative Cx plus dx is equal to 0. The value of dx is 4,000 pounds. So Cx will also be equal to 4,000 pounds. So this is the answer for Cx. And going back to the FBD of bar FD, we can say that Fy going up, so summation y is equal to 0, minus dy is equal to 0. So Fy is equal to dy, and dy has a value of 3,000 pounds. And referring back to the FBD of bar FD, we take summation x is equal to 0. So we have Fx going to the right minus dx is equal to 0. So Fx minus 4,000 is equal to 0. So Fx is equal to 4,000 pounds. So that ends all the values of the unknowns for this problem. Thank you very much.